As we move forward, the
Hello, sir.
success will always belong to who can combine the analytic thinking,
Good morning,
the
sir.
strategic vision,
Hi.
the creativity, and the human
Our
spirit.
conference is going on.
Sir, our conference is going on. We want
Lastly,
to show
I
you that.
thank everyone who's this application and very scenario participated. And I also thank the mentors. The very, very enthusiastic, excellent, and esteemed members of the
So. Hello? Hello?
Hello, sir. Can you hear us?
Yeah. Do I start?
Welcome aboard, sir.
Yeah.
Yeah, there's a
Do I
slight
start?
technical glitch.
Sorry.
Dr. Shenu Peng is the Dean of the College of Innovative Design. He's the Professor National Taipei University of Business Taiwan. He's the Honorary Professor Teaching Information Science and Technology University, China. Visiting Professor Ningxia Institute of Science and Technology, China. Adjunct Professor National Donghua University, Taiwan. Adjunct Professor Mansoor University, Mansoor, Madhya Pradesh, India, and the Adjunct Professor, Kazi Nazrul University, Asansol, West Bengal, India. His research interests include assigning algorithms for artificial intelligence, bioinformatics combinations, data mining, and networking. He's a Doctor of Philosophy in Computer Science, National Tsinghua University, Taiwan, 1999. Is the Master of Science in Computer Science and Information Engineering in National Chung Cheng University, Taiwan, 1992, and a Bachelor of Science in Mathematics, National Tsinghua University, Taiwan, 1988. Over to you, sir.
Okay. Oh, thank you for the introduction. Can you hear me? Hello? Can you hear me? Hi.
Yeah, we can hear you.
Okay.
Hello? Yes, you can start.
Okay. Yeah, good morning, everybody. It's a great honor to be invited to the international conference on data science and business analytics, ICDSBA 2025, hosted by the DSMS Institute in Durgapur, India. We are delighted to see so many distinguished scholars from around the world gathered here. In this data-driven era, AI is reshaping industry across the global, and this conference will serve as a vital platform for innovation, collaboration, and the exchange of visionary insights. ICDSBA 2025 has meticulously crafted a global melting pot where technology, management, healthcare, and data science converge to create limitless possibility for the future. This year's conference revolves around three main themes: AI-driven technology analytics, AI-enabled management analytics, and AI-driven healthcare analytics. These themes reflect not only the evolving research and the industry landscape, but also the transformative impact of data-driven decision-making on organizations and society. At this conference, we will hear from experts in many cutting-edge fields who are dedicated to exploring innovative business models, improving healthcare outcomes, and uncovering new value through data. We believe the insights shared at this conference will inspire collaboration beyond the conference hall. ICDS BA 2025 is a dynamic platform that provides everyone with an opportunity to exchange knowledge and explore the real-world applications of data science and analytics to address the complex challenge of our time. Whether you are a seasoned researcher or an emerging academic, your participation will enrich this shared journey. I encourage everyone to actively participate, speak freely, and make the most of every section, keynote address, and the discussion. Let's join hands to create innovative ideas and build a smarter, more connected, and more resilient world. Okay. Finally, I would like to thank the organizers for inviting me to this conference. Thank you all for attending, and I wish ICDSBA 2025 a successful, inspiring, and impactful conference. Thank you very much.
Sir, that was really very inspiring and motivating, and the words that you have spoken, we definitely will be very kinetic. Thank you. Our next speaker is the conference chair, ICDSBA 25, Dr. Arindam Biswas. He is an associate professor and head department of mining, coordinator center of IoT and AI integration education, industry and agriculture director, School of Geosciences and Technology, Kazi Nazrul University, head in additional charge, Department of Computer Science Engineering. Dr. Biswas received MTech degree in radio physics and electronics from University of Calcutta, India in 2010 and PhD from NIT Group in 2013. He has worked as a postdoctoral researcher at Busan National University, South Korea, with the prestigious BK21 Plus Fellowship, Republic of Korea. Dr. Biswas has received DSP JSPS Invitation Fellow at RIE Japan, DSC SEAM Invitation Fellow at Daejeon University, Vietnam, and
Hello, sir. Are you there, sir?
Hi.
Thank you, sir, for your speech. You can leave now. Have a nice day, sir.
Okay. Thank you.
Sir, can you hear us? Sir, are we audible?
Hello?
Yes, sir. You can start the speech, sir.
Now?
Over to you. Can you hear us, sir? You can start, please.
Okay. Okay. Sorry, I cannot share my screen. Hello? Hello? May I show my slides for you? Oh,
Hello. Hello.
hi.
Yes. Honest. I cannot share my screen. বলছি না মনে হয় ইউজ করছি
Hello? Can you see, can you read my message, okay?
Professor Ping, now you can you hear me, sir?
Yes, yes.
Just a second, sir. Actually, your voice is not coming, so we are actually fixing it. Okay. Give us a
Okay.
moment, sir. Thank you.
I sent my request in the messenger, in the messenger box. Please check it, okay? Now, can you see my slide? Hello? Hello? Can you see my slide?
Hello, sir. I am audible. Am I audible?
Okay. Now I will show my
Check.
my windows to you. Please check whether you can see it or not. Okay. Okay. Can you see my slide? Hello? 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 Hello?
Ha, sir, we cannot hear you actually, sir.
Oh,
Check, sir, if you could check your mute button, might be that it is muted. If you could unmute that, that might solve the problem. Your audio
it
button, sir, if you could
now?
unmute it. Yeah, yeah, we can hear now here on the phone, but we cannot have you in the connection over there.
Okay.
ফোনটাকে যদি মাইক্রোফোনে লাগানো যায় সেটা কিছু হবে ডেটা কেবলতে ট্রাই দ্যাট জাস্ট আ মোমেন্ট স্যার So you may start now.
So, can I start now?
Yes.
Yes, sir.
Can you see my slide?
Yes, sir, we can.
Okay.
We can see your slide, sir.
Okay. Let me. Yeah. Is it okay now?
Sir. Yes, it's okay.
Okay. I can start. Okay. Yes. Good afternoon. Yeah. I'm very happy to share my recent research. Okay. So it's the problem related to a coloring problem. Actually, I try to ask AI to try to solve my problem, however, failed. Okay, but anyway, I like this kind of research. We can.
Just a moment, sir. Your slides cannot be seen. That
Oh,
screen
really?
has disappeared. Yeah. Initially, we were able to see it, but now your screen is not reflecting.
Okay. Oh. Is it okay now?
Yes, yes, we can see it now, sir.
Oh, so but anyway, we spend too much time to solve this technical problem. So let me quickly go through my talk today. Okay. Yes, this is it's about a coloring problem. Okay, what is the coloring problem? Usually, it's a very traditional problem. In the coloring problem, for example, we can color a graph. Actually, a graph can model a lot of problems. Okay, a social networks, something. Okay, but anyway, this example is a graph coloring. To color vertex such that any adjacent vertex receive different colors. Okay. So another version I call it edge coloring. We color the edges such that the same requirement the adjacent edges cannot be colored in the same colors. This is a very traditional graph coloring problem. Okay, so today's my talk is about the graph coloring with connectivity property. Okay, at first I would like to introduce some terms related to the problem. A conflict-free path is a colored path with some color that occurs on exactly one edge. It means this path receive a unique color. Okay, of course the problem we need to if we want to find an optimal solution, we need to use the colors as least as possible. Okay, so for example here we color this graph on edges. Okay, but if we can check any two vertices, we can find for example we find a path. In this path this color is unique, so it is satisfy the condition. So but anyway you can check it for any two vertices. Okay, but anyway this colors is okay, so we use 4 colors, but actually 2 colors are enough. You can see are enough for this graph. For example, you can see these 2 vertices. You can find a path here, and only this edge colored in a unique colors. Of course, you can check in 2 vertices. Okay, so 2 colors is okay. So the optimal solution K is equal to 2. Actually, this problem was proposed in 2018. Okay, later we have the vertex version. It means with the colors are colored on vertices. Okay, let me show you an example here. In this example, we can check any 2 vertices. For example, here you can see in this path, this blue vertex and this yellow vertex, they are unique. So But anyway, you can check all possibility. 3 colors for this example. But anyway, 2 colors are enough here for this example. We can find any path through this vertex. Okay, so 2 colors are the optimal solutions. And this problem was proposed in 2020. Okay. Later, also not later. Also, this problem can be considered on shortest path. And this called a strong version. Okay. For example, here, because this is a path. So any path to connect 2 vertices is a shortest path. So we can, for example, use this color. Any vertex from one from here and the other from here, they receive a unique color. Okay, but if we color here and here, any vertex from this left side or the right side, they can receive a unique color for using these edges. Okay, later we can see we can color the other edges with blue color. Okay, 3 colors for this path. Actually, this is like a binary search. So the solution to solve a half it's a log 2n take the ceiling. Okay, anyway, for a complete graph, this one is called a K4. One color is enough. Because any 2 vertex, the shortest between them is just 1 edge. Okay, so it's 1 color. But anyway, for vertex version, we need different colors for each vertex. So 4 colors are necessary to color the vertex of a complete graph. Okay. So for the problem, then we can classify into edge version and the vertex version. And the traditional first problem proposed is only for a path, and the stronger version is for a shortest path. Okay, but anyway, some researchers do this problem for this and this and this 3 for this 3 part. And my research is to solve this part, and the manuscript appeared in Cocoon 2024. Okay. So today I just show some result of my research for this problem. We consider the complexity aspects. Okay. So the hardest problem is to show this problem is NP hard. Let me show you quickly. Okay, it's a little bit hard to understand immediately. Okay, but anyway, I just show you a picture how to do this reduction. For a formula with these 4 clauses, we have 3 variables. Okay, for each variable, we can draw this graph. Okay, here, and then we have 4 clauses. Okay, and for each clause, like this one, C1 is X bar, O Y and O Z. C1 is S bar, O Y and O Z, and the other similar. Okay. Then we need 4 extra vertices here, and this all component to connect to this vertex. and this one to this one, and this one to this one. Okay, so finally, if we can color this strong version and the vertex version color this graph by using three colors. Then we can solve this formula. And if we can use three colors to color this graph, then this formula is set fileable. Okay, it's set fileable. So this result show that this three strong vertex color conflict coloring connected conflict-free coloring problem is NP hot on three colorable graphs. Okay. Also, we can check this graph is also diameter 3 and domination number 3. So for those graph with this probability, it also NP hot. Okay. But anyway, we can solve in some spatial graph. We can see it will be easier. For example, the split graph. Split graph means the graph can be partitioned into two parts. One part forms a clique. Clique means a complete subgraph. The other part is an independent set, a little bit like a bipartite graph, but one part is a complete graph. Okay. And for this graph, okay, actually we have to consider two kinds of connect vertices. Okay, for example, here they show us same neighbor, and the other kind, like this one, they will have this close one edge in this clique. Okay, but anyway, by the previous discussion, I show you that in a clique, in this problem, we need the number of vertices in this clique colors. Okay, so if we let k equal to c means here is equal to 6. In this example, r is the max. This means it's u here. Its neighbor coloring, okay, but with the maximum 1 is R. For example, here you can see for this vertex, its neighbor is 6, 5, and 2, and for this vertex is 5, 4, and 2, okay, and so on. So R means here because it's the maximum, okay, here. So we solve this problem. If K is its neighbor, then we take the minimum number that are not in that is not in his its neighbors. Otherwise, is R plus 1. Now, for example, here because 6 is in its neighbor, so we take the minimum 1. And the minimum 1 is 1, okay, and not in its neighborhood, okay. And for this example, 6 is not in its neighbor, so R plus 1 is 6 to here, okay, and so on. Actually, we can prove this formula. So we solve this problem on split graph. So this problem is a polynomial solvable on split graphs, okay. Also on co-bipartite graph here, co-bipartite is a little bit like the split graph, but these two parties form complete graph. Okay, so only edges between A and B, and all edges in this complete subgraph here. We assume that the cardinality of A is at least B, cardinality of B. Okay. Assume this is the number of edge between A and B. We denote it as E, A and EAB. Okay, so we show that if EAB, the number of EAB is 1, then this we need if A equal to B, the size of A and B is equal. Then we need A the candidate A plus 1 colors to color this graph. Otherwise, the cardinality of A colors are enough. If the cross edge here is at least 2, then we show that this problem is equivalent to the traditional vertex coloring problem on the co-bipartite graph. So actually, we show that this problem is polynomial solvable on co-bipartite graph because the vertex coloring on co-bipartite graph is polynomial solvable. Yeah, finally, I will give a conclusion for my talk. And we can see, though several people discuss this problem, but only in very spatial graph. Here you can see two connected graph or graph with diameter at most 4 and so on. Okay. Also, yeah, we in this talk I show you it's a polynomial solvable on spree and the co-bipartite graph, but NP hard on 3 colorable and the diameter 3 and the domination number 3 graphs. But anyway, you can see till now there is no complete solution for trees. For these 2 papers, only very spatial trees. Yes. So yeah, is it polynomial solvable on trees is really hard for this problem. But we know later on trees, many algorithms you can use the dynamic programming approach to solve this problem. But till now, yeah, we do not know how to solve this problem on trees. Okay. So yeah, time is up. Thank you very much for your attention. Please enjoy the conference. If you have any question, you can contact me via this email. Okay. Thank you very much. Okay. Hello. Okay. Thank you. So, yeah. Can I leave now?
Thank you so much, sir. That was very nice of you.